Hi there. So this is section 3.5, calculate the rate of change. This is a handout that is not in that original big packet that we've been working on. We will go back to that. I think it's tomorrow. So this one was just kind of one that got added in later that didn't quite make the packet. So this is posted though in the Canvas modules. And again, totally up to you. If you are cool with handwriting this out, it's totally fine. It's just as like little convenient time savers why I offered it. Okay, so here's what's going on is we're talking about rates again. So we have a rate, which we already know this, is a ratio that measures how two quantities change with respect to each other. Again, our applications or story problems. It is very important to keep track of your units, so that's how you label it. And as a hint, think of the word per, like miles per hour. Think of it as a fraction or division bar. To help you set up the problem with words before using numbers. So for number 1, if a typist reports for work at 9 a.m., leaves at 5 p.m., after having typed from the end of page 12 to the end of page 48, earning $128 that day. Find the rate of pay in dollars per hour. So as the hint says, let's set it up with words before we put in the numbers and use the per as the fraction bar. So I'm going to write dollars per hour like this. Dollars per hour. The dollars, how many dollars do they mention? 128. How many hours do they mention? They don't specifically say the hours, but we could figure it out, right? Because it's 9 to 5. So that should be 8 hours. And then on your calculator, do 128 divided by 8, and you should get $16 per hour. A lot of people just leave it as $16. Don't do that, okay? Because it's a rate, so it has to be a ratio. So label it as $16 per hour. Okay, so make sure you label. Some people prefer to label a teensy bit different, and it's exactly the same to me. I'll go read you the same. 16 per hour. If you would rather do something like that, I'm fine with that. Whatever makes you most comfortable. Okay. Go ahead and try to finish the rest of this page. Okay, so try to get B, C, and that example 2. So hit pause and come back when you're ready. So part B, find the average typing rate and number of pages per hour. So write it in words, pages per hour. The pages, how many pages was it? Well, she went from 12 to 48. So I'm just going to do 48 minus 12 is 36 pages. So just one more time. I'm just going to say it once more, just so I don't lose you. Okay, that 36 comes from that page 48 minus page 12. So that's how many pages she did in that amount of time. She did 36 pages. Okay, so 36 pages over still 8 hours, right? And let's see, 36 divided by 8, I'm getting 4.5, so 4.5 pages per hour. Next one is find the rate of pay in dollars per page. So I'll write out dollars per page. The dollars we've already found out was 128. And the pages, remember that's how we got that 36 pages. And 128 divided by 36, I'm just going to go ahead and round it. I'm going to put a little squiggly equals. That means approximately. And I'm getting $3.56 per page. Okay. And this one, I just typed it on my calculator just to make sure. What you probably got on your calculator, hopefully, oops, is 3.5555, and it keeps going on and on and on, right? So I want it to go to what we typically see as cents. This is the hundredths place. So to change this guy to know whether to keep him the same or to round him up is you look at the guy next door. And if the guy next to him is 5 or higher, then this one will round up. So if this had instead been like 3.55444, it would have just been 3.55. Okay, I hope that makes sense. All right, next, example 2, the average tuition was $1,327 in 1999, and then that $1,359 in 2001. Find the rate at which it was increasing. So I'm going to go ahead and write that first as dollars over years. And you don't have to write this part. I'm just going to show all my work. 1359 minus 1327 over, it was in 2 years, so you can just write down 2 if you want, or if you want to see all the work. 2001 minus 1999. So it would be $32 in 2 years, which if you divide that, 32 divided by 2, you get $16 per year. All right. Perfect. Looks good. All right, example 3. All right, just this page. And then we're done. Example 3, we have the temperature 0 degrees Celsius is equivalent to 32 degrees Fahrenheit. An increase of 1 degree Celsius is equivalent to an increase of 1.8 degrees Fahrenheit. Let capital F be the Fahrenheit reading that is equivalent to a Celsius reading of capital C degrees. Assume F is the dependent variable. So first, find the slope of a linear model that describes this situation. What does it mean? Okay, so to find the slope, I'm going to need 2 ordered pairs. Okay, and it's said to make F be dependent, right? So I'm going to have 2 ordered pairs. I'm just going to write this down so I don't forget. I'm going to put a little C, comma F. For Celsius goes first and then Fahrenheit. So I'm going to try to gather some information in here to try to get 2 ordered pairs so I can go find the slope. So here's one. I'm going to give you the easy one, and I'm going to make you find the hard one. 0, 32. So Celsius was the first one because they said F was dependent. So Celsius is independent, and when it's 0 degrees Celsius, it is 32 degrees Fahrenheit. So now you go ahead and hit pause and try to figure out what the other ordered pair would be. Okay, I'm guessing that you knew this was a 1, right? And what did you put right here? You probably put 1.8. Is that correct, though? Should that really be 1.8? Because it says it increases by 1.8. So if you go from the 0 to the 1, you're going to go from 32 to 32 plus that 1.8. So that should actually be 33.8. Let's go find our slope. So I went ahead and subtracted, and I got 1.8 degrees Fahrenheit. So that means there is an increase of 1.8 degrees Fahrenheit for every 1 degree Celsius. Okay, what is the F-intercept? So remember, F is like our Y. What is the F-intercept of the model, and what does it mean? So remember that F-intercept is going to be wherever our independent is at 0, right? So it's going to be, they already gave it to us, 0, 32. And what does it mean? It means that at 0 degrees Celsius, it is 32 degrees Fahrenheit. Okay. I would like for you to go ahead and try to finish off the page. I think you can do it. Part D, don't get too stressed, because remember the unit analysis, if you can't find that paper right now, I'll help walk you through it, because that won't be something you get tested on. You should definitely be able to get part C though, because you have a slope, you have an intercept. Part C should be okay. And part E should be okay, because you're just going to substitute something in there. Okay, so go ahead and hit pause, try to do C, D, and E, and hit play when you want to check your work. Okay, so the equation of the model. So we're going to go with the y equals mx plus b, but remember our y, our dependent is f. So I have f equals 1.8c plus our intercept is 32. Okay, our unit analysis. I'm going to go ahead and write the equation again. Fahrenheit, we would label that in degrees Fahrenheit, equals our 1.8, that was the change, right? That was the change in Fahrenheit compared to the Celsius. So that 1.8 in units would be degrees Fahrenheit over degrees Celsius. Times Celsius, we would write in degrees Celsius. I'm going to put it over 1 since I'm multiplying it by a fraction. Plus that 32 was in degrees Fahrenheit. We have degrees Celsius on the top, on the bottom, that will cancel out, leaving me with degrees Fahrenheit equals degrees Fahrenheit. Since our units are the same, we can make the assumption that we were on the right track for our equation. Okay, looks good. Finally, if the temperature is 30 degrees Celsius, what's the Fahrenheit reading? So I'm going to write the equation. Where do you think that 30 degrees is going to go? It's going to go where the C is at. Okay, if you didn't quite make it this far, or if you didn't figure out that part, go ahead and hit pause now and see if you can finish it off. Hit play when you're ready. All right, so I plugged in the 30, multiplied it by 1.8, added the 32, went ahead and simplified to 54 plus 32 with a final answer of 86 degrees Fahrenheit. Wonderful. Awesome. That is it for today. I hope you have an amazing day.